All right, we're back with basically the last section of Chapter 8 here. I don't know if I'm going to break this in. I think I'm going to still break this into two videos because I want to show you something I found. I was going to sketch out different atoms for you, but I found this neat little program online that lets you build atoms from scratch. So we'll go do that, and I want to first show you on paper, right? So helium, for example, right? Again, we're using the planetary model of the atom for these drawings. Helium, I should show you on the periodic table. If you go to the periodic table, right, you find that helium has, atomic number of 2. And remember, the atomic number is the number of protons. And always remember, periodic tables usually come with some kind of key to them. So you can tell, okay, what am I looking at when I look at these values? So this is 2 atomic number, which is the number of protons, right? So in the center of the helium atom, there's 2 protons. And there are, helium is in row 1 of the periodic table, right? So helium has 1 main energy level. And it has 2 electrons, right? Because it has 2 protons. So for a neutral atom of helium, you need to have 2 balancing electrons. So let me put the electrons out here. I'll just label them E, E. And helium is, remember, the first main energy level only holds 2 electrons. That's the exception to the octet rule, that first main energy level. So with a full outer shell, helium does not form ions. Helium is an inert gas, and it does not react. Does not react. All right, so this is the type of drawing we're going to do. I had lithium and fluorine on here, but I think I'm going to use the software to show you what they look like. So you can sketch them out. Make sure you take some notes on this as I go through. And maybe I'll flip back and forth between the notes and the so let me just get the software up. Okay, so I found this website on well, it's a long story how I got there, but they have this build an atom section, and I'll link to this in the on Blackboard. But what I want you to notice here is we've got an empty a place where an atom goes, an empty place, right? We've got a place with a nucleus, and we've got 2 main energy levels. So we've got main energy level number 1 and main energy level number 2. Yeah, sorry, you can see my mouse because I've got this thing. It's capturing the mouse in this window as well. Watch my finger because that's. So what we're going to do is we're going to take some protons, neutrons, and electrons. We're going to throw them in here and see what atoms we get. I'm going to turn this guy off here for a minute. I have my window in the other spot. All right. So protons. What I'm going to do here is I'm going to make a helium atom like we just saw on paper, right? So here I've added helium. I can show if an atom is stable or unstable. I can show its mass number and the net charge. So right now I've got helium defined by the number of protons, right? The number of protons are telling me, I've got 2 protons, I've got helium. However, it is unstable, right? And its net charge is +2. So I'm going to add some neutrons to this. Oh, look at that. You can have helium-4, you can have helium-3. These are both stable helium atoms, right? So these are isotopes. If I add another neutron, what is this? Helium-5. This is unstable. Let me take that off. All right, so let's assume we've got a helium atom with 2 protons and 2 neutrons. Oh, look at this. The net charge is +2. So I'm going to go ahead and add some electrons. I'm going to drop it out here. Oh, and look, it goes to the main energy level. So this is a helium ion, right? It's got 1 electron and 2 protons. So this is 1 minus and 2 plus. So 2 plus, so 2 minus 1. This is a positive ion, right? If I throw another electron in there, I'm going to have a neutral atom. So this is what helium is, right? Helium is a neutral atom. It's got 2 protons, 2 electrons, and it can have a variety of different neutrons. So they do have an isotope calculator as well. So let me show you helium here. This shows you that helium atom with a mass number of 4 is found in nature at 99.999%. Now let's add a... Okay, this is an unstable helium. I'm going to take a neutron out. So helium-3. This is an isotope, but it's only found in nature at 0.0001%. So this is a really cool tool to be able to use. We did helium. Let's look next at lithium. So I'm going to, well, what I want you to do, maybe pause the video, go look at your periodic table, right, and figure out what lithium should have in terms of protons and electrons, and then we'll come back to this. All right, so I'm assuming you stopped and did that. So I'm going to add 1 more proton. So let's look at the periodic table here. So notice helium. Helium's over here. The next one up in atomic number is lithium, right? Let me show you real quick the Elmo. There we go. Okay, so on the periodic table, oops, that image is stuck. On the periodic table, lithium. So helium's 2, right? Atomic number 2. And then we go over to lithium, which is row 2, and it's got an atomic number of 3. Yeah, sorry about the zoom on this. I don't want to spend a lot of time on the Elmo, so I'll just go back to the... All right, so lithium is 3. I'm going to throw another proton in there. Oh, we've got lithium. But look, this is unstable. I got to throw in some neutrons. I'm just curious to see... Let's go to my isotope. See what... Yeah, lithium has got... So 92% of the lithium in nature has 4 neutrons and 3 protons. Let's take one away here. Lithium-6 is 8% in nature, so that's kind of neat. What about the unstable? Oops, it's unstable. Let me add a few more. My neutrons won't stay. Add a few more neutrons here. I want to add one more. Oh, this is unstable as well. Okay, so lithium-7. Let me go back to the atom. All right, so lithium-7, this is an ion. I'm going to throw in another electron here. Oh, it's a neutral atom. So we have lithium here. Lithium it's got the first main energy level full, right? And because it's in row 3 of the periodic table, you now have an extra energy level. This is energy level number 2, main energy level number 2. So lithium has 1 electron in main energy level number 2. Main energy level number 2 can hold up to 8 electrons. However, as I mentioned in the last video, the octet rule tells us that an atom is more likely to give up electrons to reach 8 if it has fewer electrons, right? It wants to get to 8, and it wants to change the electrons. It wants to move the least number of electrons around in that reaction. So lithium only has 1 electron. It's energetically better for lithium to lose an electron than to gain 8 electrons. It's not likely to gain 8 electrons, but it's more likely to lose an electron. So you're more likely to get a positive ion with lithium. This is also similar to sodium, potassium, rubidium. The entire group 1 here is more likely to form a positive ion because they all have the same, except for hydrogen. Well, ignore hydrogen for the valence comment. They all have a valence shell that's able to contain 8 electrons, but only has 1. So they're more likely to lose that electron. So that's lithium. All right, let's go next to, we're going to go all the way to the other side of the periodic table, and then I have to add a bunch of protons here. Boron. So notice if I add protons, the element name changes, right? The neutrons only affect the stability of the atom. So you have, there's carbon, what is that, carbon 14? Yeah, carbon 14, that's unstable. I'm going to add a few more protons, and we're going to get to fluorine. All right, so we've got fluorine here. Let me make it stable. Oh, sorry, yeah. So fluorine, this is mass number 19. I need to really up the number of electrons here. So fluorine. Fluorine has 1, 2, and lithium's got 3, 4, 5, 6, 7, 8, 9. Fluorine has an atomic number of 9. That means it has 9 protons. So I'm going to have to add a total of 9 electrons, to get this to a neutral charge. So let me do that. Okay, fluorine is a neutral atom. So fluorine is in the same row as lithium, right? It's row 2 of the periodic table. So that means it has 2 main energy levels, right? The first one being the only main energy level that we're concerned about that contains just 2 electrons. All the rest, we're looking at 8. So this energy level here can hold up to 8 electrons, right? But notice fluorine is, it's in group, it's not shown here the group, but it's group 7A. So it has 7 valence electrons. Now, what do you think fluorine is more likely to do? Is it give up all these electrons, or is it likely to gain 1 electron and fill this spot? And you can pause the video, or you're just shouting out the answer at the video, whatever you want to do. So it's more likely to gain an electron, right? So fluorine is more likely to form a -1 charge, right? So fluorine, a -1 ion. Fluorine will gain an electron to fill up its second main energy level to become a more stable, energetically stable outer shell. And this is why, again, this is why I mentioned the halogens, fluorine, chlorine, bromine, iodine, this is astatine, they all behave the same in that they want to grab an electron from something else. That's why these are such reactive compounds in nature. They grab electrons from other atoms or molecules, and this causes, corrosion, basically. So that's fluorine. All right, so you can go ahead and use this electron, or this, you can use this atom builder, but this atom builder inspired me to pull a song together, and why don't we go ahead and go switch over to that window, because before you can actually build an electron, you have to know the electron building, an atom. Before you can build an atom, you have to know the atom building song, which I wrote especially just for you guys, and of course, it's called Do You Want to Build an Atom? And what do you think it's sung to? Well, the other day we had family movie night and we watched, what was it called? I don't even remember the name. We watched Frozen 2. So, my wife just yelled at me from the other room. So let's sing this song. Okay, take 2 of the song. Do you want to build an atom? Sung to the tune of Do You Want to Build a Snowman, right? Disney's Do You Want to Build a Snowman? So, let's start off here. Well, I need to find my mouse, which is all over the place. Here it is. Do you want to build an atom? Do you know where protons go? They go in the nucleus, along with neutron friends, to form a stable atom core. But our atom's not complete yet. It's missing pieces not too large. Electrons need to fill the outer shell so we can balance out the proton's charge. Total number of protons tell us what the atom's named. Neutrons differ in the core, and you get isotopes, some natural, others are man-made. Finally, you have the ions. Electrons sway the final charge. Add electrons to get negative, or you can take some off to get yourself a positive charge. Now you can go and build an atom. Protons, neutrons, electrons. They are the building blocks of all the elements that make our world continue on. Okay, so there you go. That's the atom building song, and I will post the link again to both the atom builder and the isotope in Blackboard. Thanks for listening.